Actually, today really we will start to work on the course that we have. Even it's in the introduction part, but much more definition we will review today. Uh, I call today as the introduction to DIP or digital image processing lecture. Let us start with one famous word that I heard that it's from Einstein that he said that one picture is worse than thousand words. This acronym means that one picture is worth a thousand of words, and maybe that time few people understand this, but we as the person who study about the just this subject can understand it better. Even after working with the MATLAB, you will understand what these specific sentences have the meaning or what is the real meaning for this sentence. I believe that even maybe it's more than thousands of words in the image nowadays with the development that we have in the software. Okay, let us start and go ahead. What we will review today is that what is digital image, what is digital image processing, and we have some history of the digital image processing. Just these three I will try to cover for you today. First of all, an image can be a two-dimensional array. Why I said two-dimensional and why we know it as the array is that you think for the printed picture because it should come on inside of the paper or on the paper. Then obviously in the paper that you have in your hand, we have X and Y, which will be different. And Z, suppose, the Z arrow can be fixed or different. Initially, we forget the Z arrow or Z or height of the pictures on the paper and just think for the X and Y. Then in this uh, analysis, we can say we have two-dimensional array of number, which they call this as the pixel. The range and value of each pixel, or pixel has the meaning. I will tell you as the smallest part in any image. It has the value between 0 to 255. Why 255? Because they put these numbers as the minimum and maximum. Even there is a reason that we will talk more about it. But now assume that you have X and Y, which X can change up to 0 to 255, and Y can change into 0 to 55. And it's defined by some mathematical function of X, F on X and Y. Means that these X and Y, which have the value between 0 to 255, can come inside of the function of F, and as X and Y definition, they are in the horizontal and vertical uh, axis. Let us see better. Means that this function, which will be act on X and Y, can call intensity or gray level at any point of X and Y. Means that if I put any function of this uh, parameter of X and Y, this function will identify the intensity or gray level at any point of my picture. It can be some brief things regarding the digital image. And then what is image processing? The process of digital image by any computer or any, we can say, CPU, which it will covers the low, mid, and high level process. As you remember, last lecture I taught for you. For the low level, we input and output is image. For the mid level, output is attribute extracted from the input image, and high level is that recognition of some individual object on my image. Let us have the meaning of pixel, which is element of digital image, which, or let me make it much more specific. They call it the smallest part of any digital image. We can call it pixel. Let's see some figures. Suppose this is the digital image, which in 1921 they will produced from the coded tape by telegraph of printer. Some funny things about this picture is that they will send it by submarine cable between London and New York, and it will take more than a week to send these low resolution or low quality pictures between London and New York. Then hey, now if we want to compare speed of sending the image and any other things, it's very funny. It means we are near to 2021 a year, means that near to century after these pictures. And now you will see that the speed of the transmitting between the pictures is very high. Uh, anyway, next things that I wanted to show you, this is the first picture which US spacecraft Ranger 7 took from the moon, I think, and it sent it from the lunar surface, which they sent from the NASA. And now you will see that how much nice is this figure, that as the sample of image processing. Just keep these two pictures in your mind. We will talk more regarding that. But more specifically, if we want to talk regarding the digital image, we can call it digital image is the representation of two-dimensional image as the final set of digital value, which we call it pictures, elements, or picture. Then let us make it exactly some knowledge-based um, some knowledge-based definition regarding digital image that we can call it as the two-dimension and finite set of digital values or pixel. You will see that suppose if you have this shape or these elements, it will affect by the illumination or energy source, and then you can have some image system which with the help of that image system you can monitor it on the plane set up. Then you can see the output or digitalized image. What we will see that this image is mapped on something like the matrix form, and you will see that in the matrix form, now you have very near to the real shape, but this is the digitized one. We will talk much more from this. This is from your book, this pixel value typically represent the gray levels, colors, heights, and part of our image. And remember that we have the word of digitization, which implies that the digital image is an approximation of real sense. Um, Now maybe we have some experience regarding our mobile phone and quality of the image. Okay, let us see. Suppose if I put the quality of my mobile camera to 5 megapixel or 10 megapixel or 20 megapixel, and when you will zoom it, you will zoom your figure, you will interface the same experience with the figure that I show here. And you will see that some small part that can go inside of that, these small parts are pixel. And quality and the work that you can do based on the image is representing by these small part of pixel. Means that these are small dot which will make your figure. Okay, we understand what is digital image and little bit how it will create. But let us see what should be the source of any image. Uh, Scientifically, they are categorized the source of the image into these five parts of electromagnetic energy spectrum, acoustic part, ultrasonic part, electronic part, and synthetic image product by the computer. Let us see what is this source image. We can maybe have this. We have some gamma ray imaging, which they are applicable in the nuclear medicine and astronomical observation. We have some X-ray imaging, which are used in the medical diagnostic industry and astronomy industry in the sake of checking the in the application of checking the pipe, in the checking of any welding crash, in the some application like to understand the deep of corrosive or any defect on metal, on plastic, or any other product. Maybe it's nice for you to see, or maybe you are eager to know that when they will make even the airplane, they will do something like this, some X-ray imaging, to see the body of airplane and see that is there any crack on the airplane or no. Our ultraviolet band or UV band, which specifically they use in the industrial inspection in airplane, also they use, and astronomical observation, something like lithography, industrial inspection, microscopy, laser, biological imaging, and astronomical observation. These are the application for these type of image. Um, Visible and infrared band also they have another part for the image type, which in that we have the light microscopy, astronomy, remote sensing, industry, and law enforcement application. What is remote sensing in visible and infrared band? Suppose nowadays to checking the uh, the farm product, they will use this type of image and analysis this type with the help of the satellite, and then they will understand how much product of specific suppose uh, seed we have in our farm, and they can analyze the performance of any work in the farm. Just I give you this example, which is applicable in agriculture part. And a microwave band, which it will more applicable in the radar one, and the dominant application of um, this type of image is from the wave. And unique feature of imaging radar its stability to collect data over the virtuality of any region at any time, regardless of weather, ambient lighting, and condition. You know what? The main problem that we have with the figure, even maybe you will sense it, is the light. You can maybe check it. The picture that you will take at night with a simple camera, quality it's drastically terrible, or it's not good, we can say. And the figure that you will take on the good quality or medium even level camera at the night, it's totally different than what you will take. Main thing is now they will put inside the camera, there is some other sensor which integrate in that, which will help, and some algorithm to reshape the figure. Then don't think that we have much more change on camera side. We add some good algorithm as well as good sensor, means that we attach these two parts to the camera, which the quality of the image is changed by that. Then imaging in the radio band, which will use in medicine, such as MRI and astronomy again, which is more applicable, and the EM spectrum band, which I show you here, you can see the gamma ray domain, X-ray domain, UV, infrared, microfilm, and radio wave, which is indicated in this EM spectrum range according to the energy per photon you will see in this form. Let us see some examples. Suppose this is the example of the gamma ray imaging with the bone scan, PET image, and Gugness loop gamma radiation bright spot from the reactor value, which you will see here, the bone analysis that they will use. And this is the one example. And the other one, this is the X-ray imaging of the chest on the picture number A, and B is the aortic picture. C is the head of CT that you will see again the quality of this MRI picture. Number E is D is the circuit board, and E is the cognitive loop, which you can see. All this figure, as you will see, these have its application as well as its own quality, which further to these imaging, people will come and work on to have the better and better analysis from these pictures. But suppose as the UV or ultraviolet imaging, we can have this example, which is A is the normal cone, smooth cone, and Cognos loop, which I show here. Uh, Again, you will see the difference in quality, and maybe we can see the deepness of the figure. As you will see, any of these figures have the thousand of words, and you can see that more information are hidden inside of each figure. Maybe light microscopy imaging, which is more applicable in industry to finding the crash or any adoption or any advanced technology, like making the transistor, like making the sensors, or any layering job. It's showing here. And you will see the arrangement inside of the microscope. Suppose after any simple welding or any joint to product, um, we can see and observe this type of output inside of the material that we are working on. Then let us see more things about the visual and infrared imaging. You will see some crack here, which is some thematic band. Uh, it's related to some material that they have done some experiment and then see what will happen inside. In brief, we can see that we have some thematic band in some nurses, which they will show some wavelet as well as characteristic, which no, just it's good for read. Maybe with some application we will refer to this, but you will see the different band name as it's shown due to the wavelength, that how much deep you can probe inside of the material and have the different figure. Some automatic visual inspection, suppose in the drug or in the board or in the bottles or in the air bubbles and any other product. Also, these are the application. Maybe some of you see this application, which is ruled by the traffic police, and they can detect the car plate or finding the fingerprint of a person or palm print of the person, or find that suppose this $100 USD is a duplicate or no, with the help of some visual inspection as the example. Uh, just I show here that this is the area in which image detected the plates, and then that is why in the traffic rules they say that the plate should come in the middle of the core. This is some radar image, which it will shows the space born radar, which is from the mountain, because this is from the Tibet, and it shows the forest, something like that, or some MRI part, which this is from the knee. You can see the spine and have their own analysis, or some ultrasound image, which is we can have them like this. Why I bring this example, and maybe this is some ultrasound imaging, which is most of the um, women will do during the pregnancy time, to know the healthy baby and health situation of the baby. Why I bring all these to show you that we have lots of application, lots of things that we can do with the image. And still, there are lots of things which remain in this domain of the image processing. Specifically, after the DIP subject, which is introduced inside the research, there is lots of knowledge which extracted um, from the image. And even nowadays, with the definition of deep learning, so many advanced and so many nice things they will do in the real time. Image analysis. We can have some types of method which will used for image processing. There are two types, which first can be analog image processing, which can be used for hard copies like printouts and photographs, and we can have the digital one, which we are going to use with the help of some manipulation of digital image and using the computer. You will see that with the help of this supposed T image, we digitize it or convert it into the matrix form. But as we say, we have the definition of X and Y and level of pixel. But these pixel can have the value between 0 to 255. Then why we put 0? Because 0, it's exactly, we put it as the color of black, and 255, we put it as the white color. Then between these two, 127 will become as the gray color, like that. Let us go much more ahead. This 255 analysis as the extremely or maximum number, because we work on the 8-bit figure. Nowadays, maybe the figure bit is changed, but still this conception is valuable and people work on that. Let us see the common image format. We can have black and white or grayscale. One sample per point we can have. If we take 3 samples per point, then we can have the RGB or red, green, and blue. And if you take 4 samples per point, you have red, green, blue, and alpha, and something like RGBA one, which I show you here. Then, regarding the number of samples, then the bits of the figure or picture will be changed, and then we can work on this. Most of the course that we have means that this current work, we are working on the grayscale image due to its simplicity and due to its maybe better and easiest analysis uh, on the image. But really, if we want to work better, we should use an RGBA one or much more advanced form of the figure. Let us review once more the black and white image. The image, we can call it the type of the image, which is just consists of black and white. And then the grayscale image, we can call it, it's a type of the image, which is in this type of image. The name emphasizes that such image will include shades of the gray. Just see this figure and compare with the other one. Then the value ranging again, it's between 0 to 255. Till now, we understand what is digital image and which type of image we have, what is gray level, what is image itself. Let's go for the next definition, which is digital image processing. For this digital image processing definition, um, we can have something like this. Uh, just wait, please. I lost my figure. Okay. Yes, we for this type of the definition, we are focused on two major tasks. One is that we want to improve the pictorial information of human interpretation. Means that we want to give more ability for human after seeing the image and processing of image data for storage, transmission, and representation for autonomous machine perception. What I mean that sometimes it will happen. You will see the figure at first glance and you attract to one object, but really the information inside the object, inside of the image is another thing. Suppose you will see just your face, but some more things happened on that image. Suppose one more person walking in the street, or you will see one another things, but maybe at first glance it's not attract you. Okay. One of the job for this digital image processing is like that. It means that we want to give them more interpretation or more description, or maybe some people say that whatever description is inside of the image. And another thing is that this figure also should store, should transmit, and should represent for some application. Then this is the two target that we are focusing in digital image processing. Some argument about where image processing ends and field such as image analysis and computer vision start, something like that we have. But now we are not interfering that. Let them talk. We just want to learn more about this topic. Um, why do we process the image? It has developed to deal with three major problems. First, that improve the image data to suppress the uninvited uh, distortion. Second one should be the enhance some feature of the input image that already I talked. As the means of translation between the human vision system and digital imaging device, some people will say that maybe digital image device is much more better. Then we need some algorithm that alter an input image to create a new image input. And when input is image and output is also image. Let us have this example. This figure is much more famous in the digital image processing field. There is the history that even you can read it. It's very funny story about this woman. Her name is Lena, and all the people in the world, when they want to work in the image processing, they are working on this specific figure. Why they work? Because there is the variety of the color, there is the good change of the color in this figure. Otherwise, she was not very famous because you can just have a search about who was Lena and read some funny story about this person. But the person who selected that was very, mm, I think, very a knowledgeable person, because the sample he took, it's become something like standard to work. First, have this introduction about the figure. Then you will see that this image display and printing, images editing, images enhancement, and image compression that we will do. See, suppose if we will talk later about what is Sobel filter, but you will see the original image, and after processing this image by Sobel filter, you will see that picture is a little bit um, have some sharpened edge, which maybe it will be more informative for us. Um, some even you will see that in image processing we have some noisy image. This noisy image can be happen in any image, even inside of the MRI one. You will see that the noisy image of chest I have at the top, and then after doing the algorithm, you will see that it's become better, means that more informative. Or you will see the PCB that I put here. After removing the noise, what should be the quality of the image? Or you will see that this image, which is related to, or taken by the city's image, and you will see the output of the image here. You will see that noise is something that we cannot reduce, or we can reduce, but we can not delete it totally from any image. Even nowadays, for your mobile, you will see that they put some AI part, which inside of your mobile, after putting the AI, your shape is become much more better than the real image. Maybe you have the same experience. Uh, it start to remove the any crash or any things from your face. Your skin become more shiny, something like that. But these are the methods and things that people will do with the noise. You will see even one more work that people can do with DIP is that constraint adjustment. See that the high constraint, original constraint, and low constraint of the image. When we change the constraint, contrast of image, you will see that by this work, the much more information become appear for us inside of it. Suppose some edge detection job, which we will review inside of this course for the house um, and building is shown here. You will see that much more things come ahead, and you can get more information about the figure. Suppose from the brain of the people, they will use the region detection and segmentation. Suppose for the tumor work or any abnormal inside of the image. Or see the image comparison. Suppose the original image is 2.1 MB, and after comparison, the size is 50% as 308 KB. You will see maybe you will not feel much more difference between them, but this is the beauty of the algorithm, which is not lost much more data inside of the figure. And we talk, suppose, for the low-level processing in DIP as image as the input and output. An example is noise removal and image sharpening. With the mid-level of them, which input is image, but output is attributed, we can have the object recognition and segmentation, and high-level one, which this is the hot topics now. We are searching for the sense, understanding, for autonomous navigation in the DIP subject. Okay, now we understand the DIP subject. Uh, Let us have some history, some very brief history, uh, which uh, which is about this subject, and then we can maybe finish for today after this history part. Suppose in 1920, as I show you, the first application of DIP uh, was newspaper industry that with the Bartland cable picture transmission service, it will happen, and image transfer by submarine, as already we talked, from London to New York and coded for the cable transfer. That time, that was great. Uh, Further, in the mid to late of the 1920, the improvement to the Bartland system resulted in higher quality image. Then new reproduction process based on the uh, photographic technique happened, which increased the number of the tones in the image. You will see that here, the improved image and quality of the 50 tones digital image. Mm. That was very useful in the field of newspaper or news that they want to have the picture. In 1916, the improvement on computing technology and once of the space race led to surge of the work in the digital image processing. You will see that finally in 1964, computers used to improve the quality of the image of the moon taken by Ranger 7 probe. And you will see that uh, then such this technique was used into the space mission of Apollo landing. Means the significance of this job was how people could walk on inside on the moon and explore the real moon. In 1970, some digital image processing begins to use in the field of the medicine, and 1971, Godfrey and with his colleagues take the Nobel Prize for just working for the CAT image. Is that in 1979, uh, working on the image could bring the Nobel Prize for you. And 1980 till today, we can use the use of digital image processing techniques has exploded, and they are now used for all kind of tasks in all kind of areas. So and things like image enhancement, restoration, medical visualization, industrial inspection, law enforcement, human computer interfacement. More things, as you can see, the nice job of DIB on the noisy figure, which we talked already on that, or from the Hubble telescope, which launched in 1990, and the figure which it will send from the universe, and now we can analyze and even see what will happen. New field for this maybe image processing is the filmmaker and movie maker industry, which nowadays they will use with the blue, they call as the specific name to this technology, they call it blue, mm, I forgot the name. They call it green screen, yes, and blue screen, which with the help of these, they can add or remove so many parts from the actors. In medicine, also, you can see the edge detection in MRI will help the patient to see and representing any tissue density inside of the brain and any other part of them. In GIS, as we talked, to see an analysis of the uh, forest and the land and so many applications like industrial one, which we talk already about all of them. In brief, what I wanted to tell you for today's lecture was that how these topics it's enter inside our life and how it will be useful for us to understanding and work with that. I bring these lectures from this reference, and I think it's okay for today.